Okay, good afternoon. Wanted to quickly introduce, today we have Brian Ellis, one of our region managers, that's going to be talking to you about LVS controls and teaching us how we can hopefully make a little bit more money in this business. A couple housekeeping items that have been noted here. Everybody has been muted because the amount of people that are on this, removing the background noise. And we will take questions and answers through either the Q&A or chat bar, which I'll be monitoring. And again, I'm John Ribos. I'm a VP of Marketing and Sales for Myers and LVS. And I'd like to introduce to you Brian Ellis. Brian, if you want to take it from here.
You got it. Thank you, John. So appreciate everybody being here today for this LVS presentation. Again, as John mentioned, I'm a regional business manager for LVS. Some of you, I'm probably your regional, and some of you I'm not. But I'm happy to be representing LVS. My background, I've been in the industry for about 16 years. Lighting controls, emergency lighting. Started with LVS 8 years ago and have now been with LVS 4 years as a subsidiary of Myers. Most of you know that Myers acquired LVS in 2019. So before we get into the meat and potatoes of this presentation, I do want to kind of give an appreciation for all of the reps and all of the people at LVS that make this possible every day. You know, as sales agencies and as a sales manager, I'm only as good as the support that I have. So Linda and Ginger in order entry, Stephanie Jones, Kenny Carver in quotes, the production team. I mean, I can't tell you how many times I see an order come in and it's like, oh, here's your tracking. Just a splendid group that I enjoy working for or working with. And then also even more deeply with Myers and all the support system that we have built into Myers. You know, John is just one of many people that help put all these things together. So very appreciative of that. So what we want to kind of talk about here moving forward with this presentation is I wanted to give an overview of the inverter solutions that we can provide you guys. Some of this, is going to get technical in nature. And so I know the people on this presentation are at different levels. And so I'm going to do the best I can to try to make this palatable or understanding for everybody and in as simple terms as possible, because some of it gets a little in the weeds technically. So we're going to talk a little bit about inverters, what we have to provide for you for inverter solutions. We're going to talk about bypass controls, and then we're going to talk about how we can kind of put these together to make the best solutions for our customers. So instead of just being, the LVS, the bypass relay company, we really want to be known as the emergency solutions provider. So with that, let's start with the single phase inverter solutions. So on the left over here, we have what we call our micro inverters. So the 25 watt, the 50 watt, the 125 and 250. These are unique in that they can bypass a single lighting control zone on their own. They have a switched input. They also have 0 to 10 volt dimming functionality. So instead of being full light output, as we think most of our inverters are always supplying, which is pretty much true, there's now a new class of inverters where we can utilize the dimming functionality of 0 to 10 to have a larger load be supplied power from a smaller inverter, thereby saving money and a little bit better installation for your customers. So we're going to touch on that a little bit later. Then we have the SEPS M series, the 175 to 1100. This series gives you a few more bells and whistles. You want backnet integration, different things like that. There's a lot of different bells and whistles that are available on the SEPS M. The SEPS B series is only available in 4 sizes. It's 500, 1,000, 1,500, and 2,000. It's really meant to be a bare bones. You can do automatic testing. If you add that, you can have a few output breakers. But other than that, it's just your standard inverter, very low cost solution for your customers. Then we have the SEPS EM, which is a 1 kVA up to 2.5 kVA. This is a smaller footprint, also allows you to have the bells and whistles that are available on the M, but it adds in the front meter panel. This comes standard with this product, whereas with the SEPS M product, you have to add that if you want, advanced testing and you want to monitor anything from the front meter panel. And then we have the 1 kVA to 16.7, which is the IE or E series that is available for you guys. So one thing to note, inverters typically have a single switched input on the smaller units, meaning you can bypass one zone. But as you step up in these larger wattages, you're going to be controlling more than one lighting control zone, in which case, most of the time, you're not able to do a switched input. Those then would require the bypass relays that we're going to talk about later. Let's go to the three-phase. So for the three-phase solutions, we have the SEPS C3, or what we also call the D series, and that is 4.8 kVA all the way up to 50 kVA. We have advanced seismic systems for certain parts of the country where that's important, as well as outdoor units. Whether you put this SR on a pole for a ball field, or you need a CR/DR single-phase or three-phase larger outdoor unit. Whenever you get into the NEMA 3R, we're protecting the electronics, but really what you're going to lose is battery life. Batteries typically like to be at a certain temperature range, and if you go too hot and too cold, really you're just going to lose life. So if our normal batteries are 10 years, putting them outdoors, you may only get 5 years out of them. So this is more of a controls presentation. This is an inverter. I just think it's important to talk about both of them, because really what I think the solutions really require is, how do we merge these two things together, right? So we have our emergency path of egress lighting. We're going to use lighting control devices to switch it, right? So we have normally switched lights. And then what can we provide control-wise to be able to bypass the controls when utility fails, okay? So as we talked about before, these micro and mini inverters are pretty unique. You can see they're very small in size, okay? They're 25 watt, 50 watt, 125, and 250, but they are your built-in UL924 device. They also have automatic dimming using 0 to 10 volt. How does that work? So basically the concept is, instead of being full light output, let's say, I wanted to use this SEPS 250, right? And I wanted to do full light output. Well, you really wouldn't want to put a load more than 210 watts on that inverter. But if you're dimming it, and it's only available in 0 to 10, right? So if you're utilizing 0 to 10, which is most of our applications today, why not dim that load so that we can get more bang for our buck out of the product? So think about putting a 750 watt load, right, and utilizing a SEPS 250 and connecting the 0 to 10 to your emergency fixtures. What happens is, under normal circumstances, this control device in this bottom left is allowing it to turn on and off with this switched input. It also, you feed it with the unswitched input so that it knows when utility is gone, and it also allows this to feed through the inverter under normal circumstances. When normal or utility fails, all this stuff on the left goes away. The inverter outputs AC power, and it dims the 0 to 10 to 0 and slowly ramps up until it reaches its output wattage. So a 750 watt load with a 250 watt inverter is going to be roughly 33% light output. Now, one thing to note is this is only bypassing one lighting control zone. If you have more than one lighting control zone, then you have to move to a larger inverter and then the multiple bypass relays out in the space. So really, I think about, if you have a corridor and it wraps around some area, and let's say those are 3 lighting control areas, then what you would have is 3 of these micro or mini inverters. Then what I would do is I'd say, okay, how many, what's my wattage of my emergency lighting in that area? Okay, it's, 500. Well, I can choose, okay, I can use the 250, in which case I would be at 50% light output, or I can use the 125, right? So it's just really a ratio of 125, or whatever the inverter rating is, divided by the emergency load. If you're utilizing every other fixture in that space, well, that's fine. The other benefit of using this product is, now what if what if we did every single fixture in the corridor stairwell as emergency? So now I could have 750 watts of total lighting, normal and emergency. And then I could utilize my 125, right? Because now I have more fixtures that are emergency. So I can supply less light output per fixture. So I can put the 125 on the 750, right? And dim that down. Now the whole corridor is emergency. You don't have to pipe two sets of wires. It's just emergency hot and neutral and 0 to 10. So now we've started to save some extra wiring and installation for the contractor. And honestly, probably a better, outcome. We have even illumination. So one question you might have is, how much can I put on this? So we kind of wrote in here 3 times the EM load, right? So don't really want to go above 75 watts on the 25, 150 on the 50, 750 on the 250. The trick is the 125 and 250, they're actually different size batteries, but they're the exact same inverter. So we can do 750 off of the 125. So that's a little bit unique. Are there any questions about this product? I know this is kind of unique. John, anything in the chat?
No, we have nothing in the chat right now.
It's so riveting that there's nothing in the chat. Okay.
Yeah, I heard somebody snoring.
Yeah, perfect. Thank you. That's awesome. So, where are we going to put these things, right? If they're out in this space, they're not in the electric room, where are we going to put these things? So we're going to put them above the ceiling. And how do we do that? We're actually using lithium iron phosphate instead of VRLA or instead of other products that are out there, battery technologies. Really, this is allowing us to have a smaller footprint. So in this circumstance for the 125, 16 pounds. Look at some of our competitors. We're talking 42 pounds. You can't put that above a ceiling. 12-hour recharge. Isn't it interesting? If you do your yearly full discharge test at the end of the year with the other competitor, and you have an emergency situation the next day or two, that device won't work, right? So that could be a problem. 12-hour recharge, 24-hour recharge, and then this thing's only 22 pounds. So the nice thing is it has a nice grid form factor. The plate can fit on for grid mounting on either product, and it can be wall mounted or grid mounted with the same product. You just have to buy the grid mounting hardware separate. These are meant to be indoor units. Okay, if there's no more questions, let's roll back. So I kind of want to take a step back and just say, okay, let's look at our emergency system as a whole and put together the inverter as well as the bypass relay, okay? And then we can move forward. So what we have is our utility that's feeding our electrical panel. And then that's now connected to the hot and the neutral to our emergency lighting inverter, which is in green here. Under normal circumstances, this backfeed switch is closed and the power flows through freely to the emergency lights. It's also trickle charging the batteries, right? So this AC DC converter is allowing DC to go this way. And then when utility goes away, it's going to go the other way and it's going to convert DC to AC. So this actually meets NFPA 101 because our lights are on all the time, right? That's a night light or unswitched. But then we also need to switch our normal lights. So what we're going to do is we're going to pop in a J-box and we're going to put in some kind of lighting control device. It doesn't matter if it's a switch, a power pack, a relay, a room controller, whatever it is. Now this lighting control device can control my normal lights, right? So I meet ASHRAE IECC Title 24. The problem is we want to switch the emergency as well. How do you do that? How do you take a switch on utility and everything downstream from this inverter now is emergency, right? So this is utility, this is emergency. So this switch can't actually control both. So we have to add in a new device. So in order to do that, we add in an ALCR relay or what we call an EPC. Okay, what that allows you to do is take the switched output, allowing this relay to have the emergency lights on at the same time as the normal, and they'll come on and off together, as you can see here. Then we take an unswitched supervisory hot, allowing this device to understand if it has utility or it doesn't. So switched output, monitoring connection, unswitched or supervisory connection. And then we have our emergency power because we need to power this emergency lights from emergency power. So this works great. And then what happens is the switch allows it to turn on and off both until utility goes away. Our backfeed switch pops open so we don't backfeed power into the system. And now we're outputting AC power. The device says, I ignore the lighting control. Doesn't matter if this is on or off, the emergency lighting is going to be on. So this is a basic idea of how the ALCR or bypass relays function. There's different types of these devices, so let's talk about that. Okay, so there is a shunt relay, there's an ALCR relay, automatic load control relay, and an ATS, a transfer switch. These are very similar, but they meet the similar results, but they are different. So we're going to discuss how they're different. So the RRU is a shunt relay. With or without the X adds the 0 to 10 volt or dolly bypass. But without it, you can use this on 120 or 277. This is the form factor. It can be flush to the ceiling or the wall. You can take the plate off and you can screw it to it inside of a junction box. Okay, but the main thing with a shunt relay is every fixture in the lighting control zone must be an emergency light. You can't mix a normal and emergency in the same zone. That's the reason that we have this other device. And this is honestly 90% of what we see on our projects today. So the ALCR relay allows you to mix normal and emergency in the same zone. And then you can add dolly or 0 to 10 volt. It can bypass both. The difference of the A, so most of you know the EPC2 switching bypass, EPC2D adds the dimming bypass, but the A gives you this form factor with the junction box mounting. I have a slide later that's going to show both of those side by side. The other one looks similar to this, but it is important for you guys to know which one to use, so I'll kind of highlight that later. Both the shunt relay and the ALCR relay are UL924 listed bypass devices. And the reason they're bypass devices is that these devices never allow you to power the emergency fixture from utility. You're only powering emergency fixtures from emergency power. If you want to power from utility or emergency power, then you have to use an automatic transfer switch, which has to be listed UL1008. If you transfer from one source to another, the device that you use must be listed as UL1008. Let's look at how these are wired. So the simplest method is the shunt relay. So this dotted line is my relay, and this is super simple. This is the coil of a normally closed relay. The normal function is without power. So when you have power on the coil of a normally, closed relay, it's open, which is exactly what we want. So we bring our black wire and our white wire to the RRU. Then we bring the emergency, we run it through this relay out to the emergency fixture, and then you put your switch or your lighting control device right here. So it's always on the emergency switch leg. You can see this switch can never power any normal lights over here because they're not connected to it. So this is the reason that the shunt relay can only turn on and off emergency fixtures. They cannot turn on and off normal fixtures. So this allows you to get your normal light on and off. And when utility goes away, when power goes away on the coil of a normally closed relay, what happens? It closes, providing an alternate or a shunt around the control device. So this fixture will be on when in loss of normal power. Where do we use this guy? So we'll use this if we have a relay panel. Let's say you have a relay panel and you're bringing a normal circuit out to your devices, Here's an emergency circuit out to your devices. If you do not have a UL924 listed relay panel from any one of your manufacturers that you represent, you can provide an RRU in line with the emergency relay, and that will shunt the control upon loss of normal power. Okay. The other place that I see this is in fixture control. So a lot of times what we'll see is this -FM allows you to add a fixture mount package to what we already described. The RRU UNV, which is a shunt on-off. Adding in the X gives you the addition of the 0 to 10 volt bypass, and then the FM gives you the butter stick. So a lot of times this is more of an OEM play for us to ship out to the fixture manufacturers and then install in their fixtures. But it is important for you guys to know that we can ship these same day, next day. So if you're on a job and you got a problem and they can't they can't find these, know that we have these, we can supply these, we can ship it out to the contractor, install in the field, or we can ship it to the manufacturer and they can install it before they ship it out. By very nature, if the control device is in the fixture and that fixture is emergency, then the only fixtures in the lighting control zone are emergency fixtures, which makes it a perfect application for a shunt relay. But most of our applications are going to fall under this UL 924 ALCR listing. So automatic load control relay. So what's different about this? So these are the two different devices. So the EPC A2 switching -D 0 to 10 volt dimming or dolly bypass. The A gives you the junction box fit mounting, and it also gives you this automatic test switch. So I'm going to talk about this a little later because basically we have an auto test feature that gives a 2-second delay off on the emergency fixture. That's a patented option that we have on all of our products that's unique to us, and it allows the customer to be able to test their emergency equipment every time they use the space. So I have a slide later that's going to show that. And then if you want to see the device in the wall or ceiling, then I would suggest not using the A and using the EPC2 or 2D. They wire up pretty much identically. They just have a different form factor. Okay, so the coil 1 and the relay 1 is yet again the same shunt relay we talked about before. So imagine just duplicating that, right? So take a shunt relay and then make the device inside the device's dotted line, add one more relay. So the only difference of a shunt relay and an ALCR relay is there's one relay versus two relays. The ALCR adds the addition of this second relay and this second coil. But instead of being a normally closed, it's a normally open. So electrically, it's opposite. So now I can take my switch from the emergency switch leg side over to the utility side. And now that allows me to not only provide power to my normal lights, but every time there's power on the coil of a normally open relay, it closes. It does the opposite, right? So now the emergency light is following the switch and the normal lights. So they look like they're in the same zone, even though this utility power is never powering this emergency light. That's one thing to note, right? UL 924, the device never powers the emergency light from normal. Really, all we're doing is we're opening and closing two separate contacts. So this works all day long, allowing my normal and emergency lights to come on and off together until utility fails, in which case the shunt relay kicks in and provides an alternate path to that emergency fixture. John, any questions in the chat?
We're still good, Brian.
We're good. Okay, here's how one of these devices works in the field. So if I wire an EPC A2D to my emergency fixture in this classroom, and then I have my lighting control device, whatever it is, wired to all the normal lights in this classroom, whenever power fails, the emergency light is going to go on, and the lighting control device is going to be ignored. That patented test, what it does, if utility is present and all these lights are on, but I walk out of the room, I'm going to flip the switch off, the normal lights go off automatically and the emergency light will stay on for an additional 2.5 seconds. So there's a 2.5 second delay off with that patented audio or visual test. And what that does, if the customer understands what's happening, they're going to love it because they're testing their emergency equipment every time they use the space. If they don't know about it, then they might not like that functionality. So if you flip this switch in the other position, the off position, it gets rid of the automatic test switch, right? So then that visual test goes away. If you're using the non-A device, the older devices, the EPC2 or 2D, then you have this blue loop. If you cut the blue loop, that automatic test goes away. And then we also introduce a red loop. This is available on all of these. We'll be sending out a follow-up to anyone who's interested in a fire alarm white paper that shows, you know, our really old devices don't have the fire alarm included. All of our current devices do. But this fire alarm is a great idea. So whether this, you know, has teeth to the code or not in your territory, roughly about half of the states, give or take, have adopted the 2018 version of NFPA 101, which dictates fire alarm override. So think about, right now our path of egress controls and our path of egress lighting, um, our inverter, generator, bypass relays, all of this system, what it's doing is it's only providing this path of egress lighting when utility fails. So what happens if we have a fire? There's smoke covering the lighting control occupancy sensors, but the fire hasn't taken out utility. So we could be in a circumstance where we're leaving the building in the dark, which would be problematic, to say the least. So this is a good idea to provide a fire alarm override for the path of egress, even though maybe it's not adopted by your state. So just something to think about. If your state, if inspectors are calling for this, you may run into something in the future where they say, we would love for you to provide battery packs and bug eyes, but have the fire alarm override them. And then you might ask yourself, how in the world do I do that? So we make a device called a TRA2. You feed it with utility, you run the utility through this normally open, right? So then what happens is, as long as power exists, right, then it's closed, providing power on the constant hot of any UL924 device that you may have, bug eye, battery packs, whatever. Then when utility fails, it would open, thereby, turning all these devices in their emergency mode. But also, if utility is present, it allows you to connect to a fire alarm to be able to trigger the loss of power, even though we haven't lost utility. So if this is of interest to you guys or anything that we've talked about, please reach out to your RBM and we can get you more information if you're interested. Another kind of unique example that most people don't think about is healthcare. So healthcare, I mean, we look at like growing verticals in our market today, healthcare, data centers, these kind of things. Well, healthcare is everywhere. And something that, we're not really thinking very much about is we always think of these devices as our life safety path of egress devices. But in healthcare, you introduce an additional form of emergency called critical lighting. So if you have critical, it is very different from path of egress. Path of egress, you want the lights to go on and meet your 1 foot candle average egress minimum, right? Some places are 1 foot candle, some are average or 1 foot candle, but you want to bypass the controls in the event of loss of utility. Whereas with critical, we actually want the lights to work from the controls fed from critical power. So if you're ever in a circumstance where you have a lighting control device that needs to control normal and critical simultaneously, most people, what they do is they just provide another lighting control device, which, with a wall mounted aux sensor, with or without dimming, that could be confusing for the client. So instead of doing that, what you do is you take our normal, EPC, and instead of wiring it for life safety, you wire it backwards. If you look at the bottom. So now instead of the normal being on the right side, we put the critical. So the critical emergency power will always be feeding the controls and feeding the critical lights. The normal will follow the critical. So we're kind of using it backwards. When you lose normal, you just lose the normal lights, but the lights will still work from your control device from critical power. So this is kind of a unique circumstance. Again, reach out to us if you want additional information on this. EPC DMX. Okay, so this is a unique device. There's really only 3 manufacturers that make something similar, Strand and ETC. Ours is about half the cost, but really it comes with 2 devices. One is the DMX bypass. So you have 1 input and 4 outputs of DMX. You pass the DMX through, you use whatever the DMX system that you're providing, the console, the theatrical, whatever it is, and then you would set up a scene, a look, so that when you lose utility, it would recall that scene. So then this device is DIN rail mounted. RJ45 connects to this 3-phase loss device. So again, small footprint, really, really good looking small device. This device allows us to tie in all the phases of utility and a neutral so that we can monitor all 3 phases. When any dropout, we send this, well, automatically what we do is we go to this preset level, but this device can also be used to either send a contact closure or an open to any other device that you guys might have. So one of the things with, being an LVS rep, you guys have different conglomerates. You have different lighting control products, all of this, and right. So It's really hard to create a presentation that's going to fit all of that. So we want to work with you on these applications. Send it in, any of your applications, to your regional manager, and we'd like to work with you because there's lots of ways we can integrate these types of products with the lighting control systems that you have right now. One of which, just to scratch that surface is, or just to scratch that is, there's a lot of wireless stuff out there right now where they're sending a heartbeat to your emergency controls. And then what it's looking for is loss of power on the normal, on, like, let's say the controller. And whenever those devices see that loss of power, they lock on. So we can actually utilize this device to monitor all three phases of normal. And then we can send or open the contact so that that device fails. So again, lots of solutions here in our bag of tricks. We just want to be known as the, emergency solutions provider for you guys, and are open to looking at any individual project that you have. John, anything at this point? We're good?
You're good.
All right. Moving on to the automatic transfer switch. This device is very different because if you look at the wiring of it, where actually this emergency light or zone is not on the emergency switch leg side. It's actually off of the device itself. Whenever you're looking at a wiring diagram, if you want to understand if it's an ALCR or if it's an ATS, it's very simple. If the light fixture is fed from the device itself and it's being fed from two sources of power, it's very much a UL1008 transfer switch. It is not a bypass relay. So when would you use this? When you want to bypass line voltage dimming. So this allows a line voltage dimming switch. It doesn't matter, any type of two-wire dimmer, forward, reverse phase, whatever. Then this would allow you to be able to dim the normal light, and this feeds through the power to the emergency fixture. So now you can feed utility and normal, and when utility goes away, it transfers over to emergency. So this not only gives you redundancy, being able to switch back and forth, but a lot of times where I see this is like multifamily, like corridors and things, where the design might be calling for 0 to 10, but the owners provided some kind of decorative, incandescent screw-in LED replacement. If that's the case, and you have a lighting control device and half the fixtures are normal, half the fixtures are emergency, your regular ALCR is not going to do the trick. We got to switch over to the transfer switch. Okay, so this is a true UL1008 transfer device. And again, the reason is it transfers between one source and another. So there's some pretty cool applications that we can utilize with this device because of its functionality. One of which is we can provide a load shedding function. So you remember our micro dimmer or our micro inverter? So what was great about the micro inverter is it inherently had the 0 to 10 volt controls so that it could dim those. But it wasn't set at a particular level. It was based on a ratio of what's the wattage of the inverter and what's the wattage of the emergency load, right? And it's going to always output its wattage, and that's how you do that. If you have a centralized inverter, okay, so a large inverter, or you have a generator, and you want to still utilize load shedding, you can use this load shed device. And basically think about it from one perspective is on our corridor, we might have a lighting control device, we might have our ALCR, but we're still wiring every other fixture, right? So that's additional wiring for the contractor. And then we have these dark spots, right? So when emergency mode happens, we got this fixture on at full light output, this fixture on at full light output, and these full dark. So what we're suggesting is what we may be able to use, if we're not using the micro inverter for that circumstance, you can use a central inverter or generator and then put in this load shed device. And it has two settings. You can set the dip switches for 5 volts or 2.5 volts. 5 volts would get you probably roughly the same result as over here as far as your inverter or generator size, right? Instead of every other fixture at full light output, you're at every fixture at 50%. But we really don't even need that if we're using every fixture. So we can set the dip switch for 2.5 volts. And now we've simplified the wiring, right? Instead of having normal and emergency, we have one conduit with emergency, hot and neutral, and our 0 to 10. So we simplified the wiring, and we have even illumination, and we can reduce the size of our inverter and generator. So this, we think, is a really, really good solution. I have some examples later, which is going to probably put this into practical application for you. Here's kind of a visual of that, utilizing the ALCR, every other fixture at full light output and every fixture dark versus every fixture at a reduced light output. Nice little graphic here. Okay, so applications where this might work. One thing I think about is the warehouse application. So if the warehouse is everything completely open and there's no shelving or anything like that, then from a wiring perspective, it may be better to provide battery packs, if I'm honest with you. One of the big issues with battery packs we all know is, who's our customer? A contractor might want to just be off the job in a year, but our true clients, right, the end user, do they really want to swap out battery packs and 280 fixtures in a warehouse when they start to fail? No, they'd rather have a central inverter in one place, automatic testing, swap out the batteries every, 10 to 20 years, right? So there is definitely a place for the inverter, but we have to make sure that it's in the right price point for us to supply it. And so I think we found the good, product that's load shedding to be able to do that. So you can still use your centralized inverter. You can do your IoT Connect, if you wanted to test it, or maintenance from the cloud. And then we're using the 0 to 10 for the reduced light output. So let's see a working application of this. This is the warehouse that I worked on. By the way, while I'm talking about this, we have Bluebeam tools for our micro mini inverters. We also have Revit tools for the larger inverters. And we'll probably be putting on a training on how to do layouts, utilize them micro inverters and these load shed devices in the near future. So watch out for that one if you're interested. But in this circumstance, so we have, if we said every single fixture in this whole place, you'd have 280 battery packs, 10-watt battery packs, and think about the cost of that. It's insane. If we say, you know what, let's don't do every fixture, let's do every other fixture, right? So we're using these, blue diamonds here. So if we calculate all of that, these are all high bays, you're at 25 kVA of emergency lighting. If we used an inverter at full light output, we would need a 30 kVA inverter and probably price ourselves out of the job. So what happens if we reduce the light output of those emergency fixtures and we dim them down to 25%, 2.5 volts? Now we're only at a little over 6 kVA. So we can use a 10 kVA inverter with 14 output breakers and 14 of these load shed devices strategically placed to maximize up to 16 amps of lighting. So don't forget, if we're utilizing this bypass device, this is only 16 amps per lighting circuit. So we would have to break this into 14 different sections. So we have one centralized inverter, 14 output breakers. Let's say this is in the electrical room. The output breaker would then hit this load shed device. Then the contractor would wire that out to the emergency fixtures in that zone. We can zone this however they want, right? This is just the one that was particular for this application. And in this application, we were using a lighting control system where when it lost utility power on this three-phase device, this opened the connection so that the main hub that was outputting that beacon stopped outputting the beacon, and all the fixtures understood they were in emergency mode and they locked on. So all of our emergency lighting would be on and all reduced light output to 25% in this circumstance. So how does this pencil out? So this is ownership over 20 years. So if we're using the 280 battery packs at 10 watt, and this is contractor net, by the way, guys. So this is I put like 30 points on this. So think about 280 fixtures, $150 per, annual testing and labor. But then you got to buy this battery pack 3 more times to meet if it's only 5 years for a battery pack and we want a 20-year lifetime. So we're looking at $200,000 over the life of the system, the 20-year life. Looking at this from the inverter, we have one inverter, 10 kV inverter. We have 14 of these load shed devices. We got a little bit of labor to install the inverter, no doubt. And then these are 10-year batteries. So we'll probably get more than 10 years out of them. But let's say we have to replace the batteries after 10 years. We're still looking at $70,000. Ease of testing and maintenance. It's really a no-brainer in comparison to battery packs. one question that came up to me was, what happens? Yeah, that's great if you have a warehouse with one tenant, but what happens if you have multiple tenants? Well, then it might make sense to use the micro or mini inverters with the integrated 0 to 10. Okay, so still no lift required. The main difference, if you look at these two options, are with the micro and mini inverter, now we would just do a column. So then it didn't really matter, okay, this tenant is going to take up, 10 columns, and then this tenant's going to be 20 columns, or, we can change the way that the space is divvied out between tenants, and they're never going to overlap as far as the inverter equipment. So utilizing this, it's kind of a mid-step in between the centralized inverter and the battery packs, because we have 40 columns here, so we would have 40 microinverters. Still utilizing the 0 to 10, right? So still a good product. And then how does that pencil out over 20 years? Really, it's roughly about the same, maybe slightly lower cost for the microinverter versus the centralized inverter. The downside is you will have to replace 40 inverters, instead of batteries in one inverter with this application. John, still no, this is a quiet group. Still no questions?
Nope, you're all good.
All right, got one more application, guys, and then we'll open up the floor. Is, parking garages, right? So what is pretty commonplace today for a parking garage is providing the emergency, and normal fixtures with the integrated occupancy sensor. Okay, so one of the issues that you have there is anytime you have an emergency fixture with an LED array and LED driver, and you use a control device, you have to have a shunt relay inside that fixture telling it when utility drops out to ignore the control. And the problem with that is you have to feed those emergency fixtures with utility and emergency power. So that's a lot of conduit, a lot of wiring. So you can utilize the ATS transfer switch, put it in the electrical room with the normal power and the emergency power. This doesn't matter if it comes from a generator or an inverter, but think about if you draw this line right here, everything to the left is in the electrical room. And then these fixtures are all throughout the driveway, the drive area of the parking garage. So what happens is now we just run 3 conductors, which are going to be deemed all emergency, even though they're fed from utility and emergency, because everything downstream of a UL 1008 transfer switch is emergency, even though it's fed from utility and emergency. So then your load hot and your load neutral will always either be utility or they'll transfer over to emergency, feeding power to this via emergency. But then the sense line will be utility only. So when utility fails and this transfers over, we drop the sense line, allowing this shunt relay to understand its lost utility. So what we've done is we're still selling all the products that we wanted to sell, but we're helping the contractor by allowing him to eliminate a mile of conduit and only provide 1 conduit instead of 2. So I know that was a lot of information, like I said, some of which is, maybe a little on the technical side, but I think it's important to kind of go over all this stuff, if nothing else, to understand or help you guys understand that we can provide all this stuff for you. Whenever you get your application, you're working on a project, just reach out to your RBM, and then we can help you with the design, with the layout, just, give you support, whatever it is that you need, so that we can be better off, we can better serve our customer, our common customers. John, do you have anything you want to add at the end, and then we can, if there's any questions?
No, I think the main thing, looks like we got one person raising their hand. So the main thing is we would love for you guys to have an opportunity to sell more by getting more proficient in this. We're going to try to provide more of these pieces here so that you can, get some quick education, and hopefully this wasn't overly doing it. Looks like some thumbs up for you here, Brian. So good job. Thank you, everybody, for participating, for being an LVS agent, and for being a part of the Myers EPS family. Take care, guys.
Thank you.